I'll kick things off by latching on to one of those numbers that Francis referenced a minute ago. A recent study of the world's largest 215 companies found that they stand to lose about $1 trillion due to the effects of climate change. More and more companies are waking up to the fact that the climate is changing, and they need to act now, if not yesterday. At Stantec, we're helping our clients identify the risks and prioritize their actions in order to adapt to a changing climate. Take one of our utility distribution clients, for example. Back in 2019, one of their asset managers realized that they needed to adapt to a changing climate. Put yourself in their shoes for a minute. What would you do if you were in charge of managing thousands of transmission towers and hundreds of power lines? How would you protect against things like winds, wildfires, and floods? In order to prioritize their actions, they decided to hire Stantec to conduct a climate risk assessment. Our climate scientists and engineers couldn't possibly look at all these transmission towers and power lines, so we categorized them into 20 different groups, and we looked at the top 10 most likely hazards to impact the region. We found that the impact of extreme windstorms on north-south running transmission towers represented the single highest risk to this company's assets. We also provided a list of adaptation measures that they could take in order to protect themselves and become a more resilient company. But we all know that change takes time, and upgrading infrastructure is not cheap. While they were hard at work implementing these adaptation solutions, they were impacted by a massive windstorm. The map on the left shows their outage map on a typical sunny summer day, and this is what it looked like after the windstorm struck. Gusts up to 200 kilometers per hour toppled transmission towers, resulting in outages across the city and a loss of up to 20% of the tree canopy in some neighborhoods. As predicted, most of the north-south running transmission towers and lines were heavily impacted by the wind. I want to emphasize here that the client did everything right. They took a proactive approach to look at the hazards, look at the risks, and make corrective actions to protect themselves against the changing climate. Similarly, Stantec's climate scientists and engineers did a great job. Using a traditional approach, we were able to pinpoint the highest risk, which happened to manifest in just a few years. We view this story as a success story for both the client and for Stantec, because despite the fact that the winds resulted in extensive damage, it showed that climate risk assessments work, and it showed that we need a whole lot more of them if we want to make our communities more resilient to climate change. If we want to achieve this, we need to move fast, because climate change is not going to wait. What if there were a tool that would allow us to conduct these climate risk assessments faster? And what if that tool also allowed us to conduct them in more detail? At Stantec, all the pieces to solve this puzzle are out there, buried in file folders, servers, and databases. The challenge lays in wading through the data, identifying the important pieces, and fitting them all together. For climate risk assessments, the process is consistent. Risk is composed of two main parts: hazard, things like wind, storms, floods, and wildfires, and consequence, which quantifies what would happen if that hazard were to impact your asset. The key challenge that most climate risk assessments face is that there's too much data out there, and there are too many considerations to evaluate climate risk and get the complete picture. We need to use the latest climate data, and we need to look at the latest projections and look at all of the potential consequences in order to get that complete picture. At Stantec, we've developed innovative tools to address each of these issues, resulting in more comprehensive risk assessments that are being conducted in less time, saving our clients time and resources to focus on things like adaptation. Let's start with climate hazards. The best way to estimate what the future might hold for us is the results from global climate models, which simulate future temperature, precipitation, and a host of other variables across the entire planet out to the end of the century. As you can imagine, these data sets are enormous, and there's simply too much climate data to easily work with. We need to work with this climate data in order to distill it down to the important parts. Not only because there are multiple different variables and emissions pathways being looked at, but there are also multiple models being produced. There's just too much data. This is the output from 14 different climate models. The IPCC recently released their most recent climate projections, which included the output from almost 100 separate climate models. This is the output from 14 of those. And we're looking at projected changes in temperature and precipitation across North America over the coming century. But the content here is really not important. What I want you to focus on is that these data sets are enormous. And we need to use innovative tools in order to distill them down to what's important. And what's important is what is the likelihood of hazards occurring now and in the coming century. So we need to take these massive data sets and distill them down to something like this, which our clients can more easily interpret and gives them a clear picture of the hazards that they face now and in the future. So we're taking those enormous data sets and breaking them down to produce simple quantitative estimates of climate hazard likelihood at a particular location. The way that we're able to do this is by uploading the data into our climate data server. It currently hosts over 40 terabytes of climate information that can be rapidly accessed and processed to identify the likelihood of over a dozen different climate hazards. In short, we're looking at more hazards in less time. A process that used to take days now takes hours. And we're doing it with the best available latest climate projections. But of course, we know the hazard is not the only piece of the risk equation. We also need to think about consequences. When we think about consequences, the first question to ask is, what are the assets that might be impacted by a climate hazard? We can then dive into things like, what are the components of those assets? What are the hazards that might actually impact those components? When might that happen? We also need to think about what are the different types of consequences. There are economic consequences, there are safety-related consequences, as well as environmental. The key challenge that we face here is that there's too many possible combinations. And I want you to recognize that it's almost impossible. There's infinite combinations for us to look at. The traditional approach would have said to say, okay, let's take a subset of those hazards and a subset of those assets, and we'll look at the risk for those. The database solution that we've developed allows us to look at all of those possible interactions to allow us to conduct a more comprehensive risk assessment in less time. This is what that looks like. This is a risk assessment for 8 separate assets. They're further broken down into 70 separate components. Those components, of course, can be impacted by multiple hazards. So we'll look at 11 of those. Those hazards we know, however, are changing in time because we know that the climate is changing. So we have to consider multiple time frames. Here we're looking at the current period, middle of the century, and the end of the century. This is a risk assessment for almost 2,000 separate potential impacts. And we're using visuals like these to identify which ones are the highest risk. By tracking all of these dimensions of risk, we're able to pinpoint those that are the most important and display that information for our clients. In the case of the utility distribution company that I mentioned earlier, this is what that might have looked like. We would have seen that transmission towers and lines were exposed to extreme wind risk, but also other hazards are relevant, things like extreme heat and ice storms. And also there are other assets that could be impacted by climate change, things like their maintenance staff and substations. The risk assessment that I just showed, as I mentioned, was for 2,000 separate potential impacts. But the database solution that we've developed can investigate any number of assets, hazards, timeframes, consequence criteria, et cetera, to pinpoint the highest risk. The result is a more comprehensive and more objective risk assessment that gives us the complete picture, and it can be conducted in less time, saving our clients time and resources to focus on things like adaptation. In the case of the utility distribution client that I mentioned earlier, that would have meant more time for things like vegetation management, material strengthening, and asset relocation. But of course, every company is different, and every climate risk assessment is therefore different. Just think about your own company or your own assets. What are the physical assets that you own? What are the climate hazards that might impact those assets? And what would happen if those hazards impacted those assets? What's the highest priority? What is the risk that you face? Once you've been able to answer all of these questions, you'll be able to approach the most important question, which is, how will you adapt to a changing climate? Thank you.
Thank you very much, Dave.